So welcome for today's class. Today I'll still be doing portfolio theory and CAPM. So last time we finished on the portfolio theory part. So for today we'll be doing CAPM side. So I have been reminded, kindly you identify yourself by your names. Identify your names. In case you don't know how to identify, so you can just text your name. We shall be able to add you or adjust for you. Yeah, why 9 prime? Kindly text your name. So for the last class, I left you with some assignment. I don't know if you attempted or you never attempted. My guess is that you never attempted because I only received from I think 3 students. Only 3 students who attempted. So let's continue with CAPM. I want us to do directed. We do a question. We do a question. Or first, before we do the, for those who are joined today who are not in last time, let me remind you for some formulas. Let's go to the whiteboard. I need to remind you for some formulas. So under CAPM, we say that in this case, the risk will be measured. The risk was measured using the beta factor. And we say that the beta factor means the sensitivity. It's just a recap. The beta factor means the sensitivity. Then for the beta factor, I give you 3 formulas on how you can compute the beta factor. There were 3 formulas. Then we also said that the beta factor for the market, we said it's always equal to 1. Then we say that in case you have a security with beta greater than 1, we say that's what we call an aggressive security. Those with less than 1, we say they are defensive security. Defensive security. But those with beta of 0 is risk-free security. That's what we are looking at. And then we say that under CAPM, we have the CAPM equation line, or what we call the security market line equation. We said in this case, to get the return of the security, we said you take the risk-free rate plus the expected return of the market minus the risk-free rate, you multiply by the beta factor. And we say that the return of the security can also be used, or this formula can also be used to get the cost of equity or the cost of capital. So this one is the same as cost of capital. So that was the equation. So I left you with an assignment, and there was a student who tried, but akaenda mrama kidogo. Let's do it. December 2009, question 2B. December 2009, question 2B. Let's try that question. So Maridadi Limited is an all equity financed company with a cost of capital of 18.5%. The company is considering the following 1-year investment project. So we have that project A to E. Then we have the outlays. Then we have the annual cash flows. And then we have the beta. Now the beta given here is for each project. Now, for example, for A, if you're given a beta of 0.3, that means it's a defensive security. That means it's less sensitive. 0.5 less sensitive. 1, it's equivalent to the market. D, it's very sensitive as compared to the market. It's 1.5. E, it's also very sensitive as compared to the market. The risk-free rate of return is 8%. and the market rate of return is 15%. This is the expected return of the market. Required, the beta factor of Maridadi Limited. Now, Maridadi is the company, and these are the projects. But in this case, they want the beta factor of Maridadi Limited. So how do we get that? So that's August 2009. We are doing part 1. How do we get the beta? So we said that return of the security is equals to risk-free plus expected return of the market minus risk-free rate, you multiply by the beta. And we said that return of the security is equivalent to the cost of capital. And we have been told that, and the introduction, that Maridadi is all equity financed with a cost of capital of 18.5%. So already given the cost of capital for the company. So the return of the security, which is the same as the cost of capital, it's 18.5 is equals to risk-free rate. You are told that the risk-free rate is 8%, 8 plus the expected return of the market. We are given the expected return on the market was 15 minus a risk-free rate, which is 8, you multiply by the beta. So now this is what we need to get. So how do we substitute that? So it will be 18.5 is equals to 8 plus, you take 15 minus 8, you get 7. So it will be 7B. Then this one you take to the other side. So it will be 18.5 minus 8, you'll get 10.5 is equals to 7B. That means your B, you'll get 1.5. Now this is the beta for Maridadi Limited. Good. So now let's go to part B of the question. That was part A. The required rate of return and the expected rate of return for each of the above projects, indicating which project the company should undertake and which one to reject. So they want the required rate of return and the expected rate of return. And then you advise on which project to accept, which one to reject. Good. So how do we get that? So we are doing part 2. So we say that only accept the project if the expected return of the security is greater than the return of the security. So that's when we accept. So you bring the projects here. We had project A, B, C, D, and E. Then you compare the expected return on the security against return on the security. Now, how do we get the expected return on the security? Now, in this case, for the previous question we did, we already given the expected return on security. Assuming you are not given, this I'll get the expected return. The expected return, the percent of expected return, you take P1 minus PO, you divide by PO times 100. Now, this is what I mean. Assuming you had a share which was, the par value was 10, and then for now, it's trading at 15. So if you want to get the expected return, it's just the gain. So it's 15 minus 10, you get the change. That means you may gain a 5. Then you divide by PO, which was 10, the initial. 10 times 100, you get 50%. The same, you get the expected return on the security. So you take PO, I mean P1, you minus PO over PO times 100. How do you get PO? Now, based on this question, we have the outlay and we have the annual cash flows. Now, the cash inflow, this one becomes the P1. This one will be P1. Cash outlay becomes your PO. In short, you are trying to get the return. For example, project A, you had invested 1,000 and you expect to get 1095. That means you have a return of 95. So you take 95, you divide by 1,000. That's how you get that. So this is what I mean. For example, for project A, you take P1, which is 1095, you minus PO, the outflow, which was 1,000. you get the change, and then you divide by PO. You had invested 1,000. For project B, PO is 1,000, P1 is 1130. So that means itakuwa, you take 1130, you minus the initial investment, which was 1,000, then you divide by 1,000. Twende kwa C. Kwa C it's 1780, 2385, and for E is 24. Then you deduct the PO, the initial outflow. For project C, it's 1,500. The other one is 2,000. The other one is 2,000. And then you divide by PO. So here it's 1,500, 2,000, 2,000. Now for the first one, what do you get for the first one? If you multiply by 100, you get them in percentage. This one will be 9.5%. This will be 13%, 18.7%, 19.25%, and this will be 20%. Yeah, that's the expected return on the security. Now we compare against the return of the security. How do we get the return of the security? Here is the formula. Return of the security, you take the risk-free plus expected return on the market minus risk-free, you multiply by the beta. So it's risk-free, you add expected return on the market minus the risk-free, you multiply by the beta. So the risk-free rate does not change, it was 8%. Then you add the expected return on the market. The expected return on the market for the for this was 15. So you take 15. Then you deduct risk-free rate, which was also 8. Then you can multiply by the beta. Now, in this case, you are multiplied by the beta for each project. So what you are given here, the beta for project A, it was 0.3, 0.5, 1, 1.5, and 2. You multiply by that beta. So here you multiply by 0.3, 0.5, 1.0, 1.5, and 2. So we get that. So this is 10.1, this is 11.5, 15, 18.5, 22. Then we can comment. Remember the question was you determine the expected return on the security and the return of the security, and then commenting on which project to accept, which one to reject. So tukuja hapa. The first one, the expected return on the security is 9.5, but the return on the security is 10.1%. Accept or reject. So you're doing for project A. Should we accept? Should we reject? Yeah, we should reject. Yeah, we said only accept. Miandika hapa. You should only accept the project if the expected return of the security is greater than the return of the security. That's when you accept. So in this case, the expected is 9.5, but currently we have 10.1. So that one you reject. 13 and 11. So 13 is greater than this. So that one automatically we accept. 18, 15, that one we still accept. 19 and 18, that one still we accept. The expected is greater than the return of the security. Then we have 20 and 22. That one we should reject. And we say that if you reject, what does it mean? Or we come to interpret that one later. Remember, we said that when the security is undervalued, when it's overvalued. Good. Now let's go to part C of the question. Part C, you can screenshot that for a rabbit. So part D of the question is asking about the beta factor of the investment in the accepted project. How do we get the beta factor of the accepted project? Now this is what you do. So we have accepted 3 projects. The accepted project, we are getting the beta of the accepted project. We have accepted 3 projects, project B, project C, and project D. We had rejected project A and D. So you take the accepted project and then you take their PO or their capital. For example, project B, we had invested 1,000, C 1,500, D 2,000. So you take the proportion. So this one you take, it was 1,000. I'm taking the PO or the initial outflow. C was 1,500 and D was 2,000.